We were able to discover something pretty cool when trying to dissect the unit circle and using our right triangle trig, at least here in the first quadrant. We noticed that any point that was on the unit circle in this first quadrant, we could draw a right triangle, and we recognized by using our right triangle trig that those coordinates to the point on the unit circle were directly related to those ratios that we defined. The x-coordinate corresponded to the cosine of theta, remember, the adjacent over hypotenuse, and the y-coordinate corresponded to sine of theta, the opposite over hypotenuse. Well, we want to extend this idea to go beyond right triangles. We want to be able to talk about these ratio values to all points on the unit circle. Alright, so we're going to extend the idea. So, let's suppose that P is any point on the unit circle. So I placed it here. And let's let theta be the associated angle. So, given any point that I draw on the unit circle, here, let's draw another one. We could look at this point right here, Q. It would have a different angle. Okay? So if P is our point and theta is the angle that's associated with the point P, or the point that has coordinates x, y, then we are going to define the function f of theta to be equal to, or defined as the cosine of theta, which is going to be equal to x. And we'll call sine of theta g of theta, and it's going to be equal to y. Okay, so I use this notation because the notation can be tricky to let you know that these are functions of theta. So theta goes into my function box, out comes my output, which is the cosine of theta in this case, the sine of theta in this case, and we define them to be the first coordinate that's associated with that angle and the second coordinate that's associated with that angle. Okay? Let's draw an input-output box to kind of help you, or boxes to represent our different functions. So let's start with f first. So remember, our input that goes in is theta, and let's be clear here. So this theta is the angle associated with the point on the unit circle xy. Okay, so you give me a point xy and I'll tell you the theta that corresponds to it. So theta goes in, we apply this function f, out comes the cosine of theta, which we define to be x, or that first coordinate that's related to theta. Okay? We can construct a similar box for sine of theta. So again, theta is going to go in, and it's going to be the angle that's associated with the point xy. We apply g to it. Out comes sine of theta, which is going to be defined to be the second coordinate of the point that's associated with the angle theta. Okay? So, if we look back at the unit circle that we created, recall that each one of these points corresponded to a special angle around the unit circle. Well, we can now talk about this point in terms of these angles. So, for example, the cosine of 120 degrees, so what does that mean? That means 120 degrees is going to go into my input box, or my function box as my input. I'm going to apply the function cosine, and out's going to come that first coordinate. So the cosine of 120 degrees is -1/2. The sine of 210 degrees, so 210 goes into my input, my g function box. I apply the sine function to it, and out comes the second coordinate, which is -1/2. So the sine of 210 degrees is -1/2. Okay, now let's talk about our function in terms of our four representations. Remember what they are. So our four representation, remember the first was our formula. So we're going to work with cosine first. And so we have f of theta equals the cosine of theta. Okay, that's going to be our formula to represent the cosine function. Let's look at a set of ordered pairs, and we can use our unit circle to answer some of those. There are infinitely many, so we can only name a few. So let's look at f of 45. Well, remember, if we pull up our unit circle, so f of 45, 45 degrees goes into my f box, and out comes the first coordinate. So f of 45 is cosine of 45, which is 1 over the square root of 2. So an ordered pair would be 45, 1 over the square root of 2. Let's look at one more. Let's look at the function evaluated at 150. Okay, so that means the cosine of 150. Let's look at our unit circle again. So we find 150 on our unit circle. 150 goes into my function box. Out comes that first coordinate, negative square root of 3 over 2. Which means the ordered pair 150 negative square root of 3 over 2 is an ordered pair that's associated with my function. Okay? The third representation is the graph, and we are not there yet. That is a whole another set of videos. And so the last representation is in words, and so we need to figure out a way that we can talk about what we're doing, and we've been doing it through this video about applying this function. So this is how I chose to write it. The output is generated, so remember we're talking about the cosine function, by associating, or by first associating, so what's our input? That's our angle theta. First associating our input angle with its point on the unit circle. And we'll call that xy. Okay, so we're going to, first thing we're going to do is we're going to associate theta with a point on the unit circle. And the second thing we're going to do is select the first coordinate. Okay, so the output is generated by first associating the input angle theta with its point on the unit circle. So we have theta, we pick that point, or we associate that point, and the second thing we do is we pluck off that first coordinate, and out comes x. Okay, let's do the same thing with sine, our four representations. Okay, so now we're talking about sine. Our formula, we'll say g of theta equals sine of theta. Okay, notice that theta is my input. This is a function of theta. Okay, we could create a list of ordered pairs here. So what about, so let's say list of ordered pairs. So let's say g of 0 is equal to the sine of 0. If we look back at our unit circle, so that corresponds to this point right here. The sine of 0 is the second coordinate, so the sine of 0 is 0. Let's look at one more. G of, let's say, 225. That's the sine of 225. Let's look at our unit circle again. Find 225 on the unit circle. Sine of that is the second coordinate, negative 1 over the square root of 2. Great. Again, we're not ready for the graph. And so the last thing is in words. So what are we going to do? We are going to first associate theta with its point on the unit circle xy, and second, we are going to select y. Those are our four representations of our functions cosine theta, sine theta.